In this video, I'm going to propose a synthesis using Diels Alder reactions to make these two molecules. And when you're doing this type of problem, it's best to just think back to the most basic Diels Alder reaction, in which you have your dienophile and your diene, and they undergo this concerted mechanism to make a six-membered ring with a single double bond. And you need to keep track of where the carbons in this final six-membered ring came from. So it's best to just know that the two carbons that are opposite the double bond in the six-membered ring always will have come from the dienophile. So looking at this first problem here, you look at the two carbons that are opposite this double bond and just draw that. That's going to be your dienophile. It always has double bond, and then you just add in the substituents that are on those carbons. And the other thing you need to keep track of when you're doing Diels Alder reactions is that the stereochemistry is maintained throughout the reaction. So because this final product is trans, your reactants are also going to be trans for the dienophile. So you need to keep track of that. And then looking at the rest of the molecule, you see it has no substituents, so it's just your basic diene. Now problem B, it looks a lot more complicated, but it's not really too bad if you just come back and think of the most basic Diels Alder reaction. You know that the two carbons that are opposite the double bond will have come from a dienophile. So for this molecule, you have two options for that. Either this could be your dienophile, where you have no substituents on the dienophile, or this could be your dienophile, in which case you have two electron withdrawing groups. And that's another thing with Diels Alder reactions. I guess there's a lot you need to know about these. It's you want your dienophile to be electron poor, and you want your diene to be electron rich. So for this one, this is clearly a better dienophile because it has these two electron withdrawing groups. So you just draw that, again keeping track of your stereochemistry. This is going to be cis because these are both wedges. And then to draw the rest of the molecule, you're going for the reactant. So just start with, we already used these in the dienophile, so just starting here, just draw the rest of the molecule. And if we do that, and also remember that because it's Diels Alder reaction, these, if this is the dienophile, then your diene's going to start right here, and we're going to have double bonds right here. And again, stereochemistry is maintained in these reactions, and you can see that we have two methyl groups that are trans in this case. So we need to draw one methyl group and one, I guess it would be, I don't know what you would call that actually, but you have your methyl group going like this, and then because it's trans on the other carbon right here, it has to be going in the other direction. And that's how you do these problems.